over miles per hour, over nozzle spacing. I did my unit conversion, and hopefully I'm going to get 5940. So if I take this, I've got gallons per minute. I'm going to start right here. Gallons per minute. Gallons over minutes. Okay. And then I've got miles per hour down here. Well, I'm just going to call that hours per mile. Bring it up on the top. I have nozzle spacing down here, which is inches, but that, if I bring it up to the top, that's 1 over inches. So these are my units. And I need to get to gallons per acre. Okay, that's what I'm trying to get to. Well, in order to convert to gallons per acre, to get to gallons per acre, well, I've got my gallons. So I'm happy with that. What I have to do is I got some kind of time here. I've got to get rid of that time. And I've got miles and inches, mile and an inch, which have to convert to an acre. Okay, so this is my target, is to get to this. So how am I going to do that? How am I going to change this? Well, what I've got to do is, let's get rid of the time. So I'm going to multiply by 60 minutes per hour. Okay. What that's going to do is cancel my hours and cancel my minutes, and my time falls out, which is I'm happy with, because I don't want time in my final answer. I have gallons in my acres. Now what I do is I'm going to convert these to feet, because I know my conversion of square feet to acre. So 1 mile is equal to, what, 5,280 feet. And 12 inches is equal to a foot. So now I have feet and times feet now. Feet squared. So I convert that to acres. So I know that there's 43560 feet squared per acre. Good gosh. So, if I go through all my cancellations here, my minutes cancel, my hours cancel, my miles cancel, my inches cancel, my square feet cancel, and what I have left is gallons per acre. And if I multiply all those together, 60 times 12 times 43560 divided by 520, 5280, then I should get 5940. So that's kind of what I was looking for in terms of verifying that 5940 is the proper conversion. If this is in gallons per acre, miles per hour, inches, and then that your output's going to be in gallons per acre with that 5940. Okay, any questions on that? Calculating, confirming the specs of the TK2 at 30 psi, 6 miles per hour, applies 8.7 gallon per acre. All right, I'm going to do that right now. Talk about that. And so, if I have a TK2, and it's running at 30 psi, well, what's my gallon per acre? Well, I know that it's a TK2, so I have 30 psi over 10 psi is equal to Q, output of my nozzle, divided by 0.2 gallons per minute. And that turns out to be, this 0.346 gallons per minute. Okay. Now, my gallon per acre is equal to 5940 times 0.346 divided by 6, because I said 6 miles per hour. And my specifications is, it's since I'm confirming the specifications in that sheet, the nozzle spacing in the sheet is 40 inches, different than the nozzle spacing of our boom. 40 inches. And if I multiply all that out, is 8.56 gallons per acre. Now, in the book, a little bit, I think it's what, 8.6 or something? 8.7. Which is interesting because it's a little bit different, isn't it? Now, some of you use different values for this and this, which is okay. And you got maybe closer to 8.6. Go ahead. Correct.
Couldn't you just use, wasn't the 30 psi in the specs?
It was in the specs.
I mean, because I just pulled that number out of there instead of finding it.
Very, very valid thing to do. But what you found was different than this, wasn't it? Didn't it? It was like 0.35, right? Well, how'd they get to 0.35? They did this and then rounded it down, or rounded it up to 0.35. So either way is a valid way to get that number. I always go back to the standard nozzle specs, TK2s. All those nozzles, flood jets, are rated at 10 psi. And I go back to that every time because a lot of times I don't even have to look at the chart. You know, I know flood jets are 10 psi, TK2s are 0.2 gallons per minute, like 805s or flat fans. If you deal with nozzles, 805s are flat fan nozzles designed to operate at 30 psi. 805 means 0.05 gallon per minute, 30 psi, and then I'm off. So I don't even have to go to those charts to look up them. But different nozzles are going to have different standard pressures. Flat fan versus flood jet versus cone jet, and all those specs are going to be different. Because they're designed differently. They're designed for different things. Higher pressures, flat fans, are smaller droplets. Smaller droplets are more designed for a post-emergence herbicide, meaning small droplets are very effective for killing things, insects, weeds. Those flood jets, many times those are designed for either fertilizer application, if it's liquid fertilizer, or soil-applied herbicide, meaning not post-emergence, pre-emergence. And you don't need small droplet size to increase your efficacy, as they call it, or your efficiency of whatever you're applying. So you can go with larger droplets. And so that's why you have those different nozzles and different pressures. Higher pressures usually mean smaller droplets. Lower pressure usually mean larger droplets. But that's not part of the class, but that's just kind of general information about how sprayers work, etc. Now, I'm running here, and I've got a couple things that I want to cover, but any other questions on this? Okay. So, I have a challenge for you to give to me, okay? I expect you to do some of the stuff on the test. Give you a flow rate, what's the pressure, give me pressure, what's the flow rate, what's the application rate. Those are pretty standard calculations. Now, the question I have for you is you need to give me some specifications because I'm putting together a sprayer control system. Okay. And I have a certain application rate that I want to put on, and I have a certain average that I need to put on, okay, for a certain zone, maybe a management zone, and I have a typical speed at which I'm going to operate at. Okay. And I'm going to ask you to give me a number for my application rate. Any number. Gallons per acre. Application. Now, application rate is gallons per acre. Flow rates are gallons per minute. When I say application rate, it's a gallon per acre, not a gallon per minute. So give me an application rate. 12 gallons per acre. Okay. Now, give me a speed that I'm going to approximately be traveling at.
6 miles an hour.
6